Hello my dear students, welcome back to Learn Physics. In today's topic, we are continuing with our alternating current chapter. In last class, we learned about the AC circuit containing inductor. A coil is present in an AC circuit, how the changes will be happening. That one we learned. So today we are going to study about if a capacitor is present in an alternating current, in an alternating circuit, how changes will be. Current and voltage, how it will be representing. Okay. So here I am going to represent an AC circuit which include a capacitor. Okay. A capacitor is present in an AC circuit. What will happen? So capacitor means it is having charge. So V equals V0 sine omega t. This is the voltage or potential difference present in it. So that potential difference is passing through this capacitor. So what will happen? It will start charging. It will start charging, and during the positive half cycle it will charge. Then after that what is happening? It is decreasing. Right? Current is decreasing, amount of current is decreasing. Then again discharge will happen. Then it will be moving in the opposite direction, charging and then discharging. Again, this is what happening in the case of if AC is passing through a capacitor. Okay, so we know what will be the potential in the capacitor. Q is the charge passing through the capacitor and C is the capacitance of the capacitor. Then V equals Q by C. We know at any instant that EMF given will be equal to the potential of this capacitor. So we can write it as that will be equal to V0 sine omega t. Okay, V equals Q by C. Then our aim is to find out the current, how current will be varying, right? I equals dQ by dt. For that, we need the value of Q. Q equals V0C sine omega t. Therefore, d by dt of V0C sine omega t. Then V0C is common, sin omega t is minus cos omega t into omega. So we can write it as V0 omega c minus cos omega t. How we can write down minus cos omega t? Sin omega t plus pi by 2. Okay, here V0 omega c sin omega t plus pi by 2, that is I. I equals V0 omega c sin omega t plus pi by 2. So now I am going to arrange it in the known manner. That is, here I can write it as I0 sin omega t plus pi by 2. What is this I? Say I0 means V0 omega c. But as per this Ohm's law, we know I equals V by R. So in that format, if I am representing this V0 omega c, how I can write V0 divided by 1 by omega c. What is this 1 by omega c? 1 by omega c will be representing the resistance. Okay, since it is a capacitive circuit, this 1 by omega c is called a capacitive reactance. 1 by omega c is represented as XC, that is capacitive reactance, or capacitive reactance, that is 1 by omega c XC. In the case of inductor, we learned it as 1 omega L. Omega L is XL. XL equals omega L, and here we got it as XC equals 1 by omega C. So these are the equations which we are getting over here. Now we are going to just analyze the equation, how current and voltage will be varying. Here voltage we got it as V0 sine omega t, but current we got it as I0 excuse me, I0 sin omega t plus pi by 2. By comparing these two equations, voltage and current, What difference you are feeling? Here sin omega t and I0 sin omega t plus pi by 2. That means current is leading the voltage by a factor pi by 2. In the previous one, in the inductive circuit, how it was? The current was lagging behind the voltage by a factor pi by 2. Right? Current was lagging in the case of inductor, but here in the case of capacitor, current is leading by a factor pi by 2. Okay, what is the value of I0 maximum or peak value of current? What is the peak value of current? V0 omega C, or we can write it as V0 divided by 1 by omega C. What is this 1 by omega C? That is called a capacitive reactance, or capacitive reactance, that is 1 by omega C equals XC. Now we are going to draw the phasor diagram for these values. Okay, these equation we are going to draw the phasor diagram. Phasor diagram is, it's a vector diagram which is representing the value of this V0, V and I. Okay, with a phase difference of omega t, which is moving in the anti-clockwise direction. Okay, so for phasor diagram, first we are going to draw the wave diagram omega t. So V0 sin omega t. I am representing V equals V0 sin omega t. That one we can represent like this. Here current is leading by a factor pi by 2. So what is happening in pi by 2? It will be reaching to the maximum value. It will be reaching at 0 itself for current, right? V equals V0 sin omega t and I equals I0 sin omega t plus pi by 2. So here whatever value we are getting for 0, that one will be for current, it will be reaching the same value at 0 itself. What is the value which is obtaining at pi by 2? Okay, pi by 2, pi, 3 pi by 2, 2 pi by 2 pi. Okay, 4 pi by 2, that is 2 pi. So in pi by 2, if it is getting maximum value for current, the maximum value will be reaching at 0 itself. Okay, 1 pi by 2 early it will be reaching. Okay, so it is having a 0 over here. Then when it is maximum, it will be 0, and when it is minimum, here it will be maximum. Okay, we will be getting the maximum value over here, and then when it is maximum, it will become 0, and when it is minimum, again it is becoming maximum. Okay, I0 value is, it is reducing by a factor x. I0 equals V0 divided by 1 by omega C. Okay, this is the factor. Here we will be getting it like that. Now turning to the phasor diagram, vector diagram, here this is the maximum value of voltage, and here in between I am considering a point omega t. Okay, suppose if I am considering a point omega t here, this is the current value. At particular point omega t, this is the current value, and at that same point, this will be the voltage value. Right, and this will be the current value. Here I can represent current like current where it will be, it should be more than pi by 2 more than this voltage value. So current I will be representing pi by 2 more here, this one. Okay, difference of pi by 2. It is having a difference of pi by 2. This is the current value, this is the voltage value. Okay, clear children? So this is omega t. Clear? So this is how we will be drawing the phasor diagram. Now we are going to find out the power. What will be the instantaneous power and average power? Power formula we know VI. So V0 sin omega t into I0 sin omega t plus pi by 2. I0 sin omega t plus pi by 2 is minus cos omega t. Okay, so we will get it as V0 I0 sin 2 omega t divided by 2. Okay, now what is the average value of power? Average of sin 2 omega t is equal to 0. Therefore, average value of power of inductive circuit as well as the capacitive circuit, we will be getting the value as 0. Average value of power is equal to 0. Clear? So in the case of reactance, now again I am considering the reactance value, capacitative reactance, that is equal to 1 by omega c. Omega, what is meant by omega? Angular velocity. Angular velocity in terms of frequency, how we can write down? Omega equals 2 pi into nu. Okay, therefore xc equals 1 by 2 pi into nu c. For getting the more resistance, more resistance, nu value should be reduced and capacitor value should be reduced. Then only we will be getting the more value. If xc is more, if nu is less or c is less. And xc will be less if nu is more and c is more. So reactance will or resistance value in the capacitive circuit will be less if we are using more frequency, the AC circuit which is having more frequency and more capacitor. Clear? Now that is why if I am considering a DC circuit, what will happen in instead of AC in a capacitor, if we are using DC, what will be the frequency of DC? DC is having constant, it is not oscillating, so frequency is equal to 0. So what will be xc value? Xc will be infinity since frequency is equal to 0 for a DC circuit. For a DC circuit, frequency is equal to 0, therefore xc equals infinity. Infinite resistance is there. Infinite capacitive reactance is there means whether current will pass through the circuit? No, current won't be passing through a capacitive circuit if we are using a DC circuit. So current in an AC circuit it will be passing through that, but for an DC circuit, frequency of DC is equal to 0, therefore capacitive reactance is equal to infinite value. No current will be passing through that. That is why we will say capacitor always block DC. Okay, capacitor will be blocking DC values. Okay, clear children? So now we will do some numericals related to that. First question is, a 1.5 microfarad capacitor has a capacitive reactance of 12 ohm. What is the frequency of the source? If the frequency of the source is doubled, what will be the capacitive reactance? So here it is in the question, it is given capacitor value as 1.5 microfarad. Okay, has a capacitive reactance, that is xc value is given as 12 ohm. What is the frequency of the source? First one, we need to find out the frequency. Okay, next one, if the frequency of the source is doubled, if new frequency is 2 nu, then what will be the capacitive reactance? So xc dash we need to find out. Okay, how we can find out nu? Xc equals 1 by omega c. Therefore omega equals 1 by xc into c. Omega we know it is 2 pi into nu into 1 by xc into c. Therefore nu equals 1 by, what is xc value? 12. 1.5 into microfarad to farad conversion, it is 10 to the power minus 6 into 2 pi. 2 into 3.14. So here you will be getting the value in hertz. Now if frequency is doubled, frequency is doubling. If doubling the frequency, how we can find out the omega xc value? Xc value will be equal to 1 by 2 pi nu c, 2 pi into nu into c. Okay, so frequency is doubled, that is 1 by 2 into 2 pi. Xc dash will be 2 pi nu dash c, so therefore 2 pi into nu into c. What is 1 by 2 pi into nu c? 1 by 2 pi into nu c, we got it as 12 ohm. So 12 divided by 2, answer is 6. Okay, 6 ohm. Okay, clear children? This is the value of capacitive reactance. This one you can find out the answer while you are calculating. You will get it as 8846. hertz. This is the answer. Okay. So next question, a 15 microfarad capacitor is connected to a 220 volt 50 hertz source. So capacitor is given as 15 microfarad and it is connected to a 220 volt and 50 hertz source. So voltage is given as 220 volt and frequency is given as 50 hertz. Find the capacitive reactance. XC we should find out. Frequency is given nu. It's given as 50 hertz. XC means 1 by omega C. XC we need to find out. So in the question it is capacitor equals 150 microfarad. Then next is voltage is equal to 220 volt. Next is frequency equals 50 hertz. Then find the capacitive reactance XC. What is the formula? 1 by omega C. Nu value is given, C value is given. Convert the capacitor value into farad. 10 to the power minus 6. Then if the frequency is doubled, what happens to the capacitive reactance and current? Current also, capacitive frequency is doubling. Nu dash equals to nu. What will happen? See, XC will be equal to 1 by 2 into XC. 1 by XC dash equals 1 by 2 XC. Okay, this is what happening to the capacitive reactance. What will happen to the current? Current also it is asked in the previous question. Current was not there. So current I, how we can find out? I0 equals V0 divided by XC. Okay, XC value from here we can find out I0. Then I will be equal to, so IRMS is equal to I0 divided by root 2. This is RMS value which we are obtaining here, IRMS. Therefore, I0 will be equal to root 2 into IRMS. Okay, this is how we can find out the value of current. Okay, clear children? So these are some of the questions relating to this one. This is the simple questions, and while doing the revisions, after completing the chapter, when we are doing the revisions, we will do some more examples related to this. So I think this is useful for you, and if you like the channel, please don't forget to subscribe, like and share. Thank you for watching. Bye.